The world of LLM is evolving rapidly. We have moved beyond simple chat interactions to creating agents. Everybody is talking about agents. So I thought this is the right time to talk about how to create a simple ABAP agent. Now I am going to utilize the Google Agents white paper, which provides me the fundamental understanding of how an agent should be constructed. If you have not read this white paper, I would urge you to do so. It is available in Kaggle. It gives me a high-level architecture of agent and also gives me the different components that should be part of an agent. And this exact component list is what we are going to try implementing in ABAP world using the constructs of ABAP, and I'll be also using an SDK provided by Google Cloud, which is called as ABAP SDK, which comes bundled up with something called as a Vertex AI SDK for ABAP, which makes it easier for me to interact with generative AI models like Gemini provided by Google. Now the agent that you will end up creating here using ABAP can be utilized in an SAP ECC environment or in S4 environment or even in SAP BTP Steampunk environment, right? So as part of this blog post, I'm going to provide you a practical starting point. We are going to still create a initial blueprint of the agent, which is going to be a skeleton blueprint. There will be a lot of stuff that I will be mocking up, but over the period of time, we will make it more and more concrete as we will start linking with concrete use cases with SAP. Right? So in the context of an AI agent, an ABAP agent or an agent is essentially an LLM supercharged with 3 key points. Point number 1, crystal clear instructions, which this basically gives the agent its personality, the specific skills that it needs to have. Point number 2 would be the power tools. Now this basically enables agent not just to talk but also to act. We will equip it with specific ABAP function modules which will act as tools in the context of SAP, which will allow it to retrieve critical information, execute action, and even do handoffs to other agents which are specialized for certain use cases. Right? The third part would be the intelligent reasoning. This is where the LLM's inherent capability comes in, right? It can understand user requests, determine if and which SAP tools are needed, and intelligently extract the necessary parameters and then formulate a meaningful response based on the tool's output. This is basically the brain that connects the request to the action. So as I mentioned earlier, I'll be using Google Cloud's Vertex AI SDK, which will simplify my interaction with Google's generative AI models like Gemini. This SDK basically provides a class like CL generative model, which will allow me to utilize features like setting system instructions to the LLM, adding functional declarations, which are nothing but registering the tools, which in our case will be function modules built within SAP, which will be registered as tools to this particular agent. It provides me with bonus features like set auto invoke SAP functions. So traditionally, when you register a function in a tool or a tool to an LLM, it won't be auto invoked. It's the developer responsibility that once a tool has been identified by the LLM to be invoked, that you invoke the tool and provide the response of the tool as a context back to the LLM so that LLM can use it in its final response. But with the SDK, there are some magic features available out there which will auto invoke the function modules based on the tool registry and the tool identifications done by the LLM, eventually giving you the final response. When we see the demo of of a simplistic agent, you will realize the importance of this particular feature. Finally, there will be methods like generate content, which will actually invoke the model or the LLM behind the scene and give you the final response, which will be surfaced to the user based on the user query. So, not to mention that the prerequisite here is to set up ABAP SDK, which will come with a pre-bundled Vertex AI SDK, and follow the Google Cloud documentation to configure the basic connectivity setup with Gemini. I'll not be talking about this here, but probably I'll release a separate video where I'll show how to configure Vertex AI SDK, right? So for our agentic mission, for the skeleton use case that we want to implement, our goal will be to build a weather and air quality agent, right? So imagine that there will be a user who is going to ask what is the air quality like in my current location, and the agent would intelligently be figuring out how to answer. Right? And the component list is going to be piggybacked based on how the agent framework is defined. Right here, an ABAP class would depict an agent which will be part of the agent runtime, and this ABAP class, which is the agent, will be interacting with Gemini using the SDK like Vertex AI SDK for ABAP, and it's the function modules which will be registered as tools in these agents. Right? So the different components that we are going to see is there will be an abstract class which is ZCL Gemini agent base. This will serve as a foundation for all the agents that you will be creating in the ABAP environment. It will basically be used to manage resources and also define structures for strat components like tools. Right? Crucially, it is an abstract class, so the methods that are specific with specific agent implementation must be implemented by the inheriting agent. So we will create a concrete class which is a concrete agent, ZCL weather agent, and this will be the specific agent dedicated to handling weather and air quality inquiries. It inherits the base class, the base agent class, and it would provide certain specific system instructions tailored for weather related tasks, and also list the relevant tools required for weather and air quality retrieval. Right? So this is followed by the 3 tools which you will end up creating, which are nothing but function module. There will be tool number 1, which will be used to get the current location of the user based on the user prompt. Right? The tool number 2 will help us get the geocode, that is latitude and longitude for the location determined for the user, or whatever is available to me in the prompt. And the third tool will be to get the air quality. Now I will be mocking up these tools for the demo purpose, but eventually in the subsequent sessions I will be making this tool concrete. For example, the air quality tool can very well use the Google Maps air quality API, again available via ABAP SDK, and do a seamless call to that API to get the air quality. For some of this tool, I may choose to do an agent handoff to get these details from some other agent or some other means like a model context protocol. Right? We will talk about all that in the subsequent sessions. Now once I have this set up, the agent I'll be invoking with a sample report. That report is zdemo use weather agent, and this is a straightforward report which will invoke the weather agent to showcase its capability. So the framework structure can be visualized like below. There is an agent base class which is inherited by the concrete agent ZCL agent, and this agent is invoked by a sample report, and there are 3 tools that are registered for this agent's disposal, right, for it to use it based on the user prompt. So once you have this framework implemented, the report program would basically have a very simple and limited lines of code which is as below, like exactly this many lines of code. So you would be having a prompt which you would basically pass to the agent. You will instantiate the agent. There is a method called initialize agent which you'll basically call, which will set up the agent constructs, setting up its system instructions, registering the tool, and keeping it ready for invocation. And then you would simply process the prompt to get the final response. Right? And when we look at the demo, you'll see that the output comes out as below. Right? It basically behind the scene automatically uses function chaining capability to traverse through the different tools and give you the final response. Let's move to a demo. Let's look at a demo. So all this code is available to you over GitHub, and once you sync this GitHub in your web system using ABAP Git, you'll see that there will be a package that is going to be available to you to talk about a simple agent implementation. There are various other samples kept out there. For this particular blog, we will be focusing on this particular package which gives you the sample agent. This package would consist of the class that we saw in the blog as well. There is a base class which will have certain methods implemented, and many of those methods will be abstract, and the expectation here is the agent which is inheriting this base class will be implementing this method so that it is available for the base agent to execute. Right? So the key methods out here are something like process prompt. and which internally uses the Vertex AI SDK for ABAP, and this one line is all it requires for it to call Gemini and pass the prompt and get the response from Gemini, right? And everything else is shielded for you behind the scenes as part of the SDK. Now there are other methods like the register tool, which we'll see how this gets used. This is again using Vertex AI SDK to register the different function modules as tools to the SDK, right? And this method is the one which will basically call once you initialize the key agent, and this will basically set the instructions, instantiate the Gemini model, basically set the instructions, and register all the tools, and also set auto invoke SAP function modules as true in order for us to enable the function chaining or the tool chaining capability. The second class is the concrete agent class, which would end up inheriting the base class, and all it needs to do is to define key methods like get system instructions, where the role of the agent or the behavior of the agent will be defined on what it's supposed to do. And the second method is to define the tools. Here is where you'll see the tool 1 is the function module get current location that is registered. The tool 2 is the geocode that is registered, and the tool 3 is the air quality function module that is registered. And if you notice, for the tool 2 and tool 3, there are certain parameters defined. Basically, it is as part of the function definition, we are telling to Gemini that when this particular function has to be called, you are expected to receive these parameters, which will help the function writer to use the parameters and do actual actions or retrievals of the data, right? Now, when we look at this particular functions, these are nothing but function modules. Now, these are mocked up for now. Here, for example, when the current location of the user is been called, I'm mocking up the data. The current location is Bangalore. Similarly, in the geocode 1, I'm mocking up that the latitude and the longitude for the Bangalore location is so on and so forth. And then for the air quality, I'm mocking up again here, right? Now, the program which we'll use to test this is this report program. And as I mentioned earlier, you will be passing the prompt, instantiating the weather agent, initializing the weather agent, and then processing the prompt, right? Let's execute this and see what happens. So here I'm asking what is the air quality in my current location, and the agent is being invoked by the report, and I get a response that the current air quality index in Bangalore is 34.7, right? Now, to elaborate on what's happening behind the scene, what I'm going to do is I'm going to set up certain breakpoints. The first breakpoint I'm going to set up is right when the prompt is been passed to Gemini, that is this particular piece of code. And the remaining breakpoints I'm going to set up is in the tools. Executing the program again, and I'm keeping the prompt saying what is the air quality in my current location. Now, if you look at what's happening here is the prompt is been sent to Gemini via Vertex AI SDK, and the SDK is getting kicked in, and the SAP function modules which you have marked for auto invocation is getting triggered. Here Gemini came back and said that in order for me to give a response to your question, what I need is the current location. It was able to identify that it needs to call the tool which would give it the current location of the user, right? And the tool number 1 gets invoked here, right? Where I'm currently hard coding the location. Followed by this, the tool number 2 is getting invoked, where Gemini, once it understands that, okay, now I got the location, as next steps, I need to get the geocodes. So let me look at my tool registry, whether I have a tool which will give me my geocodes, and it finds a tool and it tells to the SDK, go ahead and invoke this tool, right? And in this case, the function module get geocode gets invoked. And here also I have mocked up the response of the latitude and longitude. And finally, once it gets this response, Gemini is going to use that particular piece and call the final tool, that is get air quality. Let me at this point show you the function parameters. If you look at the function parameter, it has been changed. The response that you got from tool number 1 and tool number 2 has been provided to the tool number 3 as well, because I asked it to do so as part of my function declaration. And now this parameters is what I can use to act or get more details from any external APIs, retrieve those details and give it back to Gemini for it to get the real-time data and construct the final response for me, right? I'm going to let it execute, and here is the final output. Now I'm going to run this again, but I'm going to tweak my prompt a bit. I'm going to say, what is the air quality in Bengaluru? And let's see what happens in this case. The prompt has been sent to Gemini. And if you look at that, tool number 1, which was supposed to get the correct location, is been skipped. Because in the prompt, Gemini understood that I don't no more need to get the current location of the user, as the location is already mentioned in the prompt. And I may move on to tool number 2, which is to get the geocodes for Bengaluru, right? And in this particular function call, the function parameters is going to get the exact location which was mentioned in the prompt for you to go ahead and write the appropriate code to get the geocode. Again, I can get this geocode from Google Maps API, which we'll see in the follow-on sessions. After tool number 2 is been invoked, the third tool, the air quality, it has been invoked as expected to get the final response. Again, the response is mocked up as of now. So that was a quick demo. You can implement this using a ABAP Git in your system and run through it. Coming back, what I will try and do in the follow-on sessions is I will try and show you how an ABAP agent can interact with something called some agents which are developed on top of Vertex AI engine using agent development kit, right? I'll also try and show you how I can interact with model context protocols, right, via agent development kits. So there will be more elaborations to this agent skeleton, and I'll try to make it more and more relevant and more robust on how we can truly make it an agentic way of solving a business use case or a use case on top of SAP using ABAP SDK or Vertex AI SDK for ABAP, which are all the different SDKs provided by Google Cloud. So stay tuned, and till then, happy learning and happy innovating. Thank you for listening.